Hey, how are you?
Hey, what's up?
Not much. How are you doing?
Hold on, give me a sec. What were you saying? I'm sorry, I was connecting my
Oh,
headphones to
yeah.
the computer.
Oh, no, I was just saying, yeah, how are you doing?
Good, good. I was like, oh my god, he's not gonna answer.
Yeah.
Um, have you been tutoring a lot of people?
um, kind of. Yeah.
Cool. Okay, so I mean, I want to do as many questions as maybe we have time because I know you have someone at 7.
Mm-hmm.
I already finished all the section banks and I'm gonna take a full then tomorrow,
Mm-hmm.
but I'm not done with the section bank for chem and physics.
Okay.
So, okay, so let me open it. Mm, okay, I think we left off on question, was it passage 3? Is that AMC doesn't have the question number, so it starts where it left off. Like, it's something like 10 out of 60 or something like that. So
Mm-hmm.
I know it's passage 3 and it says liposomes derived from compound 2 are prepared from. So I believe it's, let me see. Um, 1, 2, 3, 4, 5, 6. The sixth question from passage 3.
Okay. So which part of the section bank is that?
Oh, chem physics. I
Okay.
mean, the physics.
All right. So, okay. So, do you want to share your screen? Because for some reason I can only see like, I think I only answered 22 out of 100 for that, and I don't know. It doesn't let me see my previous score
Um,
report.
okay. Because I have it open and. So, but wait, if I share my screen, then you're not going to be able to share yours with your iPad.
Um, I think we could mutual. I have it so multiple participants can share simultaneously.
Ah, okay, okay. Cool. Okay, that's fine.
Okay. All right. Well, I remember this one.
So we stopped here.
Mm-hmm.
Oh, you mean you remember like doing it before, or?
Oh, like us working on it, or maybe we didn't work on this question, but I remember us working on the passage.
Yeah, we were working on this passage. So the last one we did. I think this is the last one from this passage, though.
Okay.
Oh, okay,
Yeah.
yes. Don't worry. I just
Okay.
remembered that before we were done, I want to ask you about one question from the
Sure.
biopath that was like super confusing. I like worked on it, but I still didn't get it.
Okay. Sure. Oh, all right. No, I figured out how it can make me see all of the questions that I've answered. So, yeah, which one do you want to go over?
Do you want me to stop sharing them?
Is that the one you want to go over?
Yeah.
Okay. Let's see. Passage 3, okay. Oh, yeah, did that focal point question make sense?
Oh, yeah. So, I mean, that question did make sense. It was not, the problem was not with that particular question, because I remember you saying like, oh, it doesn't really matter which one you assume to be the image distance or the object distance, because they're both 3 and 4. But then when I was going over another question,
12 and
I
4?
I always thought that the image distance was like the distance that the focal length was the distance between the sensor and the actual lens.
Yeah.
And then when I saw that, I was like, why they're assuming that the image distance is the same as the focal length?
Oh, yeah, yeah. It's not. Um, the focal length or the focal point, like that's where it would produce, like if the image distance is at the focal point, or rather the object distance, it'll just produce like the same size, inverted real image.
Mm-hmm.
Yeah, and yeah, before that, like if it's like outside of the range of that, there's like the optics guide.
You sent me something that was actually pretty cool.
Here, the link
That you
is in the chat.
on the chat.
Mm-hmm.
Um, okay. Reddit has been like my best friend all of this days. They have everything. Honestly, you could study for the MCAT out of Reddit. That's it.
Mm-hmm.
Well, on the internet, like what you were saying about like
Mm-hmm.
looking up everything. Like ever since I started lecturing with you, I've been like literally
Mm-hmm.
googling everything. Because what is the
Yeah.
point of going back to the books? It's like
Mm-hmm.
stupid. So.
Yeah. So this is the optics ultimate guide that I wrote. So that table really helps out. Like I have that like memorized. So you know before like you take the MCAT, when you go to like, or when they give you like some time, um, like before you start the test, I would write that table out.
Mhm.
Yeah.
Oh wait, I don't know where I left the question. Oh, there you go. Okay, so this table, got it, got it.
Oh yeah, yeah. So that's a very good one to memorize.
Mhm.
So okay, for any diverging lens or any diverging optical device, right?
Mhm.
It could be like a mirror or it could be a lens. It's gonna do the
Mhm.
same thing no matter what. Like the object distance doesn't matter, the image distance doesn't matter. It's always going to produce a small SUV, means smaller upright virtual image.
Okay. Yeah, one
Yeah,
second.
but for converging stuff, it's gonna be different.
Mhm. Okay, for converging, yeah, it was based on what you were telling me, depending on if the focal point was actually also the focal length, I believe.
Oh yeah, yeah. Those are the same things.
Uh huh.
So for converging, so this is how it works. Like let's say that the object distance is at infinity.
Mhm.
Do you have like that guide, the table, the Reddit thing that I sent you open?
Yeah, yeah. The
Okay,
thing is that
okay.
I have another screen
Oh,
now, so I'm
nice.
looking at it right now.
So you've adopted the multiple screen thing. That's good.
Yeah, actually, it was my boss. She was trying to get rid of hers, and it's
Yeah.
like a little bit wider than usual. And she was like, "I'll sell it
Mhm.
to you for like $100." I was like, "I don't know if that's expensive or not, but
Yeah.
I'll get it."
So this is like one of my monitors right here.
Yeah.
And
How many
then
monitors do you have?
then I have this one, which is vertical,
Uh-huh.
and then this one over here.
Oh my gosh. How many monitors do you do like trading or something like
Yeah,
that?
I do actually.
Oh, that's why.
Yeah.
Well, that's one of the reasons why.
Mm-hmm. Yeah. So yeah, I'm big on the multiple monitor lifestyle. But yes, anyway, so you all right, so if the object distance is at infinity, right, it's going to create an image that is at the focal point,
Okay.
and the type of image it makes is a tiny inverted real. So real images will always be inverted.
Okay. Why do you say the tiny part is that important? The
Oh,
tiny
yeah.
inverted real.
So as the object distance gets closer to the optical device, you're going to see this pattern of it getting from like tiny, which is really small, to same size, to larger, to no image, to larger but virtual.
Okay. And
So yeah.
sorry, the S is small, uninverted virtual, right?
What which one are you saying? Oh, U
'Cause-
means upright.
Oh, upright. Okay.
Yeah.
Okay.
So yeah, so basically like as you get closer, as the object gets closer to the actual optical device, it's going to produce like larger, like the size of the image produced will become like larger. Yeah, so object distance. So like an example of that is like, have you ever like used a magnifying glass to like burn things from like the sun?
Yeah.
Okay, so the sun is an example of the object being an infinite distance away.
Okay.
And the thing that is produced by the magnifying glass is a smaller, like really tiny, inverted
Right.
real
Super
image.
like focused
Yeah,
image.
yeah. So that's like basically just an image of the sun that's made.
When you say that I equals F,
Yeah.
so the image distance equals the focal point.
Correct.
How is image distance? But what would be the image there in that example that you gave me?
Oh, the sun.
Oh, I thought that was the object. Isn't the object the one that's producing the rays?
The object is the sun as well.
What? Okay. So the sun is both the image and the object?
Yes. The image is always going to be, the image of the object.
Okay.
Yeah. And so here, let me share my screen. Oh wait, let me open up whiteboard. So I'm writing it in whiteboard first because it's faster. So yeah, this is like the thin lens equation, right?
Mm-hmm. Oh, you're not sharing your screen, but I don't know if you mean to share it right now.
What's up?
Are you trying to show me something? Because remember, the only one that's sharing is me.
Oh, I'm sharing also.
What? No, I can't.
Are you able to see it? Okay, try not sharing, then it might come up.
Stop sharing us. Okay, cool.
All right. So you see the thin lens equation, right?
Mm-hmm.
So, if the object distance is infinity, right? 1 over infinity is basically equal to 0, right?
Yes.
So, if we plug this into this equation, right? This thing turns into 0, right? So 1
Yes.
over f is equal to 1 over I. Because this turns into 0. So
right.
Yeah, so when the object distance is infinity, the focal length and the image distance is equal.
Oh, that's why I equals S. Got it.
Yeah.
Cool.
So, okay, so that's, the tiny inverted real image that's produced. Yeah, that's why I is equal to F. All right, now let's say that the object distance is at 2 times the focal length.
Mm-hmm.
So, so when it's that, the image will be between 2 times the focal length and the focal length.
Okay. The image will be 2 times. No, the image will be.
Yeah, it'll be between.
Okay.
Yeah.
The focal length and 2 times the focal length.
Mm-hmm.
I don't understand why.
So it's because here, let me see if I can find a good kind of example here. Okay. And 2 times the focal length is basically the radius of the
Right. You
thing.
sent me the image. The picture you sent me 2 times the focal length. Yeah, because the focal length is 1/2 of the radius.
Correct.
Correct?
Yeah.
Okay.
So if 2 times the focal length is equal to 1/2 of the radius. Oh no, sorry. You said just the focal length, right?
Yeah.
So if the focal length is equal to 1/2 of the radius, and
Right.
we double both sides, you'd get 2f is equal to just the radius.
Right. So whenever the object distance is greater than the radius, basically, the focal length, the image distance is going to be between 1/2 of the radius and the radius distance.
Correct. Well, wait, sorry. Yeah. Correct. I showed.
Oh, yeah, it's right here.
Mm-hmm.
Well, sorry. But yeah, there's a point where they're, okay.
Mm-hmm. Yeah, so I just wrote this other thing. Don't pay, the lens maker equation isn't really that important, but this is where the radius of curvature comes from.
Okay.
Yeah, so the focal length basically is dependent on the index of refraction, which we don't have to really worry about now, but also the radius of curvature.
Okay.
Mm-hmm. So that's just, yeah, so that's that. Let me see if I can find another thing. Okay, this will also be useful. Whoops. So this is just an example of these. So for instance, so here you see the object. So okay, C is whatever, the center of curvature, which is basically just whatever, 2f.
Mm-hmm.
Okay. So yeah, so when the object, so that's the 2f part. This is the focal length, which is just f, right?
Correct.
Okay. So this is the object, right?
Yeah.
So when the object is further than the radius, right, of curvature, it's just going to it's just going to produce. Here, let me see if I can find a better one. Where you could see the I guess how things change as an object gets closer and closer. to the optical device. Let's see if I could find that. I'm trying to look for it, something like that in Google Images. Oh, here's actually a better image. I'm going to erase these. So this over here. So this is a better example. So like let's say this is like the optical device.
Mm-hmm.
And you see how it's incorporated in this circle, like this part over here?
Right.
And this part is incorporated into this circle?
Right.
All right. Now, like, one end of this circle to the 2F over here, that's the radius.
Correct.
Yeah. And then, this over here, the F, is just half of the radius.
Right.
Okay. So yeah, focal length that's basically how you determine it. It's just a property of the radius of curvature.
Okay, but you were explaining to me that if you go up to the other image that you were showing me, that if it was a converging lens and then the object was farther away than the actual than C, which is the radius, then something was going to happen, and then you showed me this image.
Yeah, because that it wasn't really what I wanted to focus on.
Oh, okay.
But I do want to find something as you get closer. Let's see.
That's very cool how you're I was reading on your Reddit thing, and you were talking about the relationship with the eyes and the corrective lenses.
Oh, yeah.
And then someone comments, I didn't understand a word of this.
Oh, yeah.
And now I'm wondering if I chose the right field. But it's pretty cool. I was just starting to read it, but, I mean, it's amazing how, you put things in relationship.
Yeah, that's almost the key. Because then you don't have to remember a bunch of disparate facts. You can just make, you can just make, by making connections, you can figure out, anything that they throw at you.
Yep.
So, and, they talk about that in the psych section, our memory is based on on semantic nodes.
Mm-hmm.
So, our brains, they're just like a neural network, basically, like a web.
Right, and then the more things you have related, and then you just have one cue that helps you recall one event or one concept will lead you to recall the other ones as well. If you already made the relationship between them.
Correct. Yeah. Pretty much perfect. Cause if you don't remember the table, right? So I wrote converging optical devices will produce ever increasing inverted real images. So, as the object gets closer, it'll go from a tiny image to something that's small, then same size, then large, and then, once it's within the focal length, it'll remain large, but it'll be virtual.
Got it.
Yeah. So the the eyeball thing, so that is basically something where let's see, where basically the focal point is it should be, so okay, in what you see here, so I'll just copy and paste it here.
Oh, okay.
Yes. So basically here in this eyeball thing, right? So okay, this over here is the image distance right there, right?
Mm-hmm.
However, this over here is the focal length.
Hmm. Okay, that's a focal length.
Yeah. So basically, so this is for if your eyes for me, like for instance, I'm nearsighted, so I need to wear glasses. Because
Okay.
without my glasses, and it just means that my eyeball is longer. Like a normal eye is about 2 centimeters long. But my
Like that, like the radius is
oh, just like
like wide
the length of the eye, like I guess from like here to
to like
like
the actual
yeah,
pupil type of thing. Okay.
correct, yeah. So my eyeball is longer than it should be.
Mhm.
So that's why it produces an image that's in front of the focal point. And the focal point is also where the retina is of your eye, and that's where you want the
Mhm.
image. That's where you want the image to be.
Correct, because that's where you would actually. I mean, those are the receptors, but
Mm-hmm.
I mean that makes sense as you say. Because I was trying to associate like why is the image there, but
Yeah.
yeah, the focal
So.
point.
Mm-hmm.
Yeah, I was like, isn't the image supposed to be on the actual retina?
Yeah. Yeah. So basically, like it's the image is basically at a point where it's like with it's within the like focal point, like it's not at the focal point. So it's basically just going to produce like a tiny well, it's basically just going to produce the image where it's not supposed to be. So that is going
Oh,
yeah.
wait. So
Mhm.
you're saying that this is an eye that is not supposed to be that way? Is that way? Is
Correct.
it supposed to be that the image is in the focal point?
Yeah.
Oh,
Mhm.
now it makes sense. So this is like an eye that needs glasses, pretty much. So
Exact
because
yeah.
the image is, um, I guess, ahead of the or like
Mhm.
away from the focal point.
Yeah.
And then the one in the bottom will be the correct one after you include the glasses, which is
Yeah, which is a diverging lens.
a diverging
So
lens.
it causes the light rays to diverge before it hits the cornea, which acts as a converging lens. So that allows the image
That's
to be
insane.
equal
Oh my
to the
gosh.
focal length. Yeah.
That is crazy.
Mm-hmm.
How long did it take? I mean, like, did you just like came up with this? I know it sounds very stupid, but like people don't put this in association at all.
Mm-hmm.
But now that you think about it, it's like basic optics, what they do
Mm-hmm.
for glasses.
Yeah, yeah, exactly.
Yeah.
So like, underneath it is someone with hyperopia, which is farsightedness. So their eyeballs
Mhm.
are shorter than they should be. So I should just say like eyeball length. It should be 2 centimeters long, like 2 centimeters. If you're myopic, then your eyeball length is going to be greater than 2 centimeters, and if you're hyperopic, it'll be less than 2 centimeters. So here is an example of a farsighted eyeball, which is shorter.
Mhm. Mhm.
So the focal like so the focal length. I mean, like the focal length or whatever focal point is here, like where the retina is, but the image
But
produced
the
is
image is.
past it. Yeah,
So what you do is you get a converging lens because you want to bring the rays closer, so that
exactly,
the image actually comes to where the focal point is.
exactly.
Cool. That's really cool.
Mm-hmm.
All right. I think I'm gonna remember that table better if I remember this example. Most of the examples that you have shown me that I'm like, I still remember the one from Peridium, and I
Oh
keep
yeah.
telling people about it, and they're like, oh, like, what is the point, you know?
Oh yeah,
Like,
yeah.
that's stupid. I'm like, okay, whatever. I
Uh huh.
think it's really cool.
Yeah, yeah, yeah. These are like the things that like I guess I don't know. I like separate like the high scorers from like the really high scorers, I guess. Just being able to think about it in in psychology, they in the PS section they call it elaborate rehearsal. So that's that's what it is. It's like you have a rich understanding of something, and that's like the best way to like learn something.
Cool. Okay. Let me see where we left off on. Well, I think I can do. If you said that we already did this one, then the one that we were going to do on that passage.
I'm not sure if we did that exact question, but I do remember us working on that passage.
Okay, that's fine. I'll do that one, because I think now I'm looking at the next one and it says it's about the hydrolysis of ATP, and I think we already did that one as well. So it's fine according to the passage. Okay, let me show you the question that I was going to tell you about.
Mm-hmm.
Am I sharing my screen? I don't know if I... No, right? No, I'm not.
No. You can try it though.
Okay. Okay, I'm going to share my screen now. So it was, why did I say that I got it right? Oh, okay. I was like, I didn't get that question right. So this question, I basically had, I guess, a wrong concept. And at this point, I do understand enzymes and everything that has to do with the relationships between Bmax, KCAT, and all that stuff. But I'm going to tell you why I still don't understand this question. I don't know if you want to read it first, or maybe you already know the answer. But
well,
I thought
first of all, you're going to look at the extremes. So it seems like you did that.
What's that?
Oh, first I would just look at the extremes. Wait, and it seems like you've already done that. But anyway,
what do you mean the extremes?
Oh, just like I would first look at the KMs. So the smallest one is Roman numeral 1. Largest one is Roman numeral 4. And then for Vmax, smallest one is Roman numeral 3. Largest one is Roman numeral 4. So okay. In terms of Roman numeral 4, I see like two things that are like one thing that's the lowest and one thing that's the highest. Roman numeral 1, I have one thing that's the lowest, and Roman numeral 3, I have one thing that's the lowest also. So what we have to do is catalytic efficiency.
Right, so I think I got the concept wrong in the sense that, well, what enzyme would have the highest catalytic efficiency? That one that has the highest Km, correct?
No, actually, because Km, remember, it's something that it's just the substrate concentration at which.
Oh my God!
Yeah.
No. Oh my gosh! I thought. Oh shit! You know what formula I was using? I was using Bmax equals Kcat times the free enzyme concentration.
Oh yeah.
So I always made the association that Bmax is directly proportional to Kcat, or they're pretty much the same because Kcat is like the number of seconds it takes for one substrate to be converted, and then like Bmax will be, Kcat is the number of substrates in 1 second or 1 unit of time, and then Bmax is the number of seconds per one substrate. Yeah. So I was like, they have to be directly proportional. But then for some stupid reason, oh my gosh, and you don't understand how long it took me. I was like, maybe I have a wrong relationship about KCAT and BMAX, so that's why I went for the highest BMAX, because I thought that they were talking to me. When they asked me about highest catalytic efficiency, I assumed that the second column was KCAT.
Oh, yeah. Efficiency is always going to be a ratio of two different values.
Right, so it can't be in plain moles. It has to be like, in this case, the KCAT is going to be moles over second. Sorry, seconds over moles.
Well, let's see. KCAT. I think it's KCAT over KM maybe. Let's see if that would make sense. So that's moles over liters, or rather, whatever number of substrate per second times liters over moles. Moles. Okay. And then let's see, Vmax is just moles times like moles over minute. So let's see, Vmax would be moles over minutes. So okay, I think what we can use is, so wait, you said Vmax is equal to KCAT times the enzyme concentration, right? Okay, and yeah, so Vmax and KCAT should be proportional. That makes sense.
And how is KM?
I think that's the efficiency aspect of it. Where yeah.
I know. I understand. Now I kind of remember again. So why wouldn't, if Vmax and KCAT are directly proportional, then why wouldn't it be Roman numeral 4 based on the fact that it has the highest Vmax out of all of them?
Because since we're dealing with efficiency, it's going to be a ratio of that and something else. I think KM, I think.
Oh, okay. So it has to be the one with the highest Vmax and kind of like lowest KM?
Yeah. Like, it's going to be, like, different for different things. So, like, let's say we did Roman numeral 4. That would basically just be something like, I don't know, let's see, like 60 divided by 1e negative 3. The 60 is just 6e1. So this is going to be 6e...
What do you mean the 60 is 61?
Oh, 6e1.
Oh, I was like 61?
Yeah.
Okay. 6e1, yeah.
Yeah, so then that'll be 1 minus negative 3, or 6e4. So that should be for Roman numeral 4. Now let me look at Roman numeral 1. So that's going to be 2e1 over 1e negative 6. That will be 2e7. And
well, you said it was that Roman numeral 4 was 6e negative 4?
Oh, just 6e4. So, 6 times 10 to the 4th power.
Right, but, I mean, aren't you dividing exponents? So it should be 1 minus, minus negative 3. So that's 64. Okay, sorry.
Yep. Yeah, and then let's see.
Math.
2 would be, 1e1 over 1e negative 4. And that would be 1e5. And then Roman numeral 3 would be 1e... Wait. Oh, wait, I skipped.
Yeah, I think that was Roman numeral 3.
Yeah,
no?
yeah. I skipped Roman numeral 2. Okay, so Roman numeral 2 would just be 5e1 over 1e negative 5. So that'll just be 5e6. All right.
Okay.
And the largest one is Roman numeral 1, 2e7.
2e7. Okay. So the catalytic efficiency, or KCAT, is a measure of, well, the conceptual definition would be the number. I'm trying to, like, instead of memorizing a formula, because pretty much the Bmax equals KCAT times
I
the
sent you a
enzyme.
link in the chat. Tell me if that works.
Let me see. Chat. Okay. Oh, you sent me a link to a Microsoft.
Whiteboard?
Okay.
Does it work readily?
It's asking me to log in, but it should.
Okay.
Nope.
All right. Let's see what I can do. Because I do have it so multiple participants can share simultaneously. So let's see if I can share my whiteboard. Okay. And let's see if I could see what you are sharing.
Yeah, it says something went wrong, an error occurred.
Mm-hmm.
Yeah, I don't know what that means.
Okay. Well, I mean, I'm sharing. All right. So I'm sharing my whiteboard so you can see like what I'm doing. And then for the questions, I have the AMC thing in front of me, so I can just look at whichever questions I have.
Got
so yeah, so right here I wrote down, I suppose like the math for the different ones.
Mm-hmm.
Yeah, for the different Roman numerals.
Right. Yeah, no, I understand that part. I just want to know, like, why did you do the relationship of Bmax over Km, in terms of, like, explaining it? Because, I mean, based on the formula that I told you about, like, Bmax equals Kcat times the free enzyme, I was assuming that it's like a linear relationship, more or less, or type of like a linear relationship. But then it seems that you have to take into account the Km.
Mm-hmm.
But isn't the Kcat like an intrinsic characteristic of the enzyme?
It is. Yeah.
So Kcat is also equal to Bmax over Km.
Kcat V max over like enzyme concentration, I believe. Let me go to that question. Okay.
No, well, it says Km, so I believe it's...
Yeah. So I guess the Kcat
KM
ratio...
it's because you assume the same enzyme concentration for all of them.
Yeah, that's when you use, the that Kcat part. Let me see if I could find where I talk about that equation. Let's see. I thought I just had it. Oh yeah. Okay. So for Michaelis Menten.
Mm-hmm.
Oh wait, not that one. I'm trying to look for where I wrote like the Michaelis, like the derivation of the Michaelis-Menten equation.
Mm. Okay, that's fine. No worries. I mean, take your time.
Uh, yeah. I mean, it
Because
could possibly be in
I
the
mean,
thing
like,
that I shared with you.
oh, go ahead.
Oh no, it might be in the notebook I shared with you. Let's see. Or maybe not. Okay. Yeah. When I find it, I'll just send it to you.
Okay. So, I mean, why would the cake? Well, okay, if you find it, just send it to me. I just want to know, like, where do you include KCAT when the enzyme concentration is pretty much constant or is the same throughout the whole comparison?
Yeah.
There's
So,
there's a similar question on the physics chem tab that says when performing, or let me share my screen really quick.
yeah.
Um, when performing experiments to measure the KCAT, the substrate concentration should be.
Let's see. Alright, to measure the KCAT, substrate concentration should be saturating.
Oh no, this is easy. Yeah, never mind. I thought it was similar to the other question in relationship to the other question. Never mind.
No, it's true. Like that's something like that's what's meant by that's like a Michaelis-Menten assumption.
Right, but basically what they're asking you in that question is what is the definition of KCAT, which is the efficiency of the enzyme at saturating concentration.
Yeah, that really just means that enzyme concentration is basically at a concentration at which all of the enzyme is being used.
Mm-hmm.
So, okay, I think I may have. All right, I found it.
Okay.
Um. So. So okay, let's see. What did I write here? Michaelis-Menten V naught is equal to V max times substrate concentration over Km plus substrate concentration. Okay. Oh, okay. Okay, I think that could help. All right, whatever. I can't I can't find it for some reason, but
It's
yeah. So we can come back to that once I find it, but it's basically just dealing with that equation. Oh, I actually found another question about focal point, but anyway.
in the QPAC?
Um, I'm not sure where it's from. It's in a notebook with
Oh.
that I have with someone. Um, but anyway, what's the next question? Unless you had
Okay,
anything
so
else on that. Any other questions on that one that we just did?
no, that was my only question on that QPAC,
Mm-hmm.
pretty much. I guess I just want to know like whenever you find the formula,
Mm-hmm.
I want to know like why is it that word,
Mm-hmm.
kind of like associating it to KCAP. If E is, because if E was different, I guess it would be a relationship of E max over E.
Mm-hmm.
But in this case, it's something else. Okay. I think we can go back to the chem and physics.
Okay.
Why do I not see any like physics questions on this QPAC? Like actual physics is mostly chemistry.
Mm-hmm. Yeah, there isn't that much straight up physics on the exam.
Like no formulas or anything like that.
I mean, it comes
To
up
be
like
honest with you,
in the.
that's what's like concerning me the
Mm-hmm.
most. To be honest, like, cause I feel I have improved in the other sections, but I know my chem and physics is going to be low. At least for
Well,
the physics part.
let's wait and see. But yeah, don't worry too much about it. When it comes up, it'll come up.
I'm trying to find a question about um like kinematics or
Like if they do ask you some questions in physics, it's going to be, like kind of like that question that you had with the focal length and stuff.
mhm. No, but oh wow, I'm like almost done with the QPAC and I
Mm-hmm.
haven't found anything. Because if I don't find anything, then I would ask if we can go over, because I had a couple of questions about lab techniques. Like, there was one about isoelectric focusing, and there was one about affinity chromatography that
Mm-hmm.
I kind of like wanted to go over with you. I mean, there's a
Yeah,
bunch of like
we could do it.
packs of lab techniques, but
Yeah, we could do it.
let me see. Let me just make sure that there's no other question here. Well, okay, this one. Or maybe it's like a concept question, but I'll still
Which question?
share it
And
with you.
it's in the
I'll share it.
Oh, okay. Oh, that's cool. Okay. So, to determine a protein's thermodynamic stability, chemical denaturation studies can be performed, assuming that only native and unfolded states can be observed under experimentally available conditions. What is the most likely shape of the curve for the dependence of the fraction of folded protein upon denaturant concentration? Okay, so like I think it's either going to be like sigmoidal or hyperbolic, but let me see.
Mm-hmm.
Only the native and unfolded states can be observed. So that means that we can only observe it when it's completely like normal and when it's completely denatured.
Correct.
So, okay. So what is the most likely shape of the curve for the dependence of the fraction of folded protein upon denaturant conditions concentration? Oops.
Concentration.
Mm-hmm. Okay, so So we're basically doing something that would have like let's say like y-axis the fraction of the folded protein, and then x-axis like the concentration of whatever thing makes it denature.
Okay, yeah, so denaturant on the y-axis, and then what's on the y-axis?
Just the I guess
how can you
the
quantify
fraction of folded protein.
Okay, so folded versus, or like folded to unfolded?
I suppose, yeah, you could do that.
Okay. And why do you say what's sigmoidal?
That's just what I think. Um, let's see. Like, I was gonna think, because that gives you like basically like both of those things, like both, like the S-shaped curve gives you both. Um, so
Because I guess the sigmoidal will be, as the denaturant increases, it's gonna increase the ratio of unfolded to folded. So then at some point the denaturant is going to be so high that the protein is not really going to unfold anymore.
So
or
I think
why is it?
so. Okay, so I think like so it's basically saying that we can only observe the unfolded state um and the folded state. Yeah, only like those two extremes.
Oh, so nothing in between. It's not like we can observe the transition of the unfolding to the folding, the folding to the unfolding, right?
Yeah. So I'm thinking, because a linear is just straight, straight line. Wait, let me see. Check this out again. So dependence of the fraction of folded protein upon denaturant conditions. So okay, so they're trying to say, like, what would the shape look like if you wanted to see how much the concentration of the thing that denatures it, like how much of that, or how much of the fraction of the folded protein depends on the concentration of the thing that causes the denaturation.
Also, in that case, I would say linear, because if you're asking me for the relationship between the denaturant and the ratio of the folded protein, or the fraction of folded protein that's present, I would say that, well, not even linear, but I mean, in simple terms, I would say the denaturant will start decreasing or like unfolding the protein until it reaches a certain point where the protein can't unfold anymore.
Mm-hmm.
So that dependence would be kind of, I guess, what is this shape? Not sigmoidal, really. I mean, kind of like goes up and then it stays, like kind of like a Microlise-Menten curve, like a saturating type of curve. But
assuming only the native and unfolded states. Wait a sec. Oh wait, that's unfolded states. Oh wait, no, sorry. Okay, it's exactly what I thought. I'm trying to look for this question in my whatever answers.
You want me to choose sigmoidal to see what they say on the answer?
I'm just trying to look for it because it says 69 out of 71.
Oh, that's because like I said,
What's
the doesn't have like a way to give you what number you're in. It's based on the ones you have left.
What's like the one that comes before that? The question that comes before that?
I think it's
which of the following peptides? Okay. Or like...
It's after passage 12 though.
Oh, okay. So let me see.
So 2 questions after passage 12.
So, alright, let me just keep going through these. Oh, okay, yeah. It's sigmoidal.
It's sigmoidal?
Mm-hmm. So, okay, so...
Reparative process.
Yeah. Like, that's like a cooperative... So they're kind of saying it just to know it, that it's cooperative. But I think I would choose it based on... Let me see. So, sigmoidal curve for denaturation. Yeah, so okay. What the reason that I would choose it is because for a sigmoidal curve, you can only see like the flat parts of it.
I'm sorry, you cut up in that part. For a sigmoidal curve, you can only see the flat part?
Yeah.
Well, no, because it's like an S shape. So, I mean, you'll see the flat, then it goes up, keeps going up, and then it stays flat again.
Yeah. Here, I shared my screen, so I'm going to draw like the different kinds of curves.
I'm gonna stop sharing.
Okay.
Okay.
It was like hyperbolic, linear, exponential, and then sigmoidal. Why can't I erase? Got it. Okay. What? Sorry, I hit some button. So,
Don't worry.
Okay. Okay, so
So that one would be the sigmoidal, right? The last one.
Yeah. What would this one be?
Okay. Exponential. No, parabolic.
No, this one's exponential. Good.
Oh, exponential, that's linear, and then the other one will be hyperbolic.
Yeah. So, by the way, what you're saying with parabolic, like, is correct. It's just, like, because that, on that end, forms a parabola.
Mm-hmm.
And hyperbola would look like
will be
that.
an inverted... Oh, hyperbola... Oh, I thought the hyperbola was an actual inverted U.
Yeah, it is. So, it's basically like if you had an exponent that is, odd.
Okay.
Oh, wait, no, my bad. I think I drew a logarithmic one. My bad. So...
For the first one.
Hyperbola. Yeah. So, sorry. So this should be... something like that. And like that. Whoops.
Yeah, that they never meet. Okay, got it.
Yeah. because this is like, y is equal to x squared. This would be like y is equal to x to the third power, like something odd. And then this would be like y is equal to x. Sigmoidal doesn't really have an easy thing like that. But the reason that I would choose sigmoidal is because for this and this and this, there's no like flat area that you can observe. It's just constantly changing.
Okay.
And there's
so those two flat areas translate to the two unfolded and folded states of the protein, right?
Correct. Because they said that only the native and unfolded forms can be examined or observed through experimental conditions.
Right, but what about that little hill that's going up right
we
there?
can't observe that.
Oh, so technically that will be erased in the actual results. Right, okay, now I get it. You picked sigmoidal because it's the only curve or the only graph that has two flat states. Okay.
Yeah, their explanation doesn't really go into that. Their explanation just says cooperative, whatever, binding or whatever results in a sigmoidal curve.
How is that important to I don't even know.
That's just saying you need to know it, but this is like the reasoning behind it because there are flat regions. So that means that we can, see like when it's native and we can see when it's unfolded.
Okay. Perfect. Oh, look, the next one is actually, do you think it's related to the graph of the K-cat? It says a combination of Km and K-cat with which relative values? It's indicative of the lowest catalytic efficiency.
So yeah, this is asking
that's literally the
catalytic
same thing.
efficiency again. Yep. So I guess like it's just good to memorize that now. Like catalytic efficiency is just K-cat over Km.
Catalytic efficiency is K-cat over Km, but isn't catalytic efficiency K-cat?
That's just catalytic turnover.
Oh,
yeah.
Right, okay.
Any efficiency question is going to be like a ratio of something.
Okay. So catalytic efficiency is K-cat over Km.
Correct.
So the one with the lowest technically would be...
so it's proportional to K-cat and inversely proportional to Km. So we want something with a high K-cat and a low...
Km.
Yeah.
High K-cat and low Km.
Oh, wait. What am I talking about?
Oh, high Km and low K-cat.
Lowest catalytic efficiency. That's what they're asking for.
Wait. Lowest.
So it's going to be the opposite.
With a low Km and a high K-cat. No, but I thought that Km was inversely proportional.
Correct. But the question's asking which one has the lowest catalytic efficiency?
Right, so you want to get something with a low K-cat since K-cat is directly proportional to catalytic efficiency.
And a high Km, good.
Low K-cat. Oh, sorry, I was looking at C. Okay, got it, yeah.
Yeah,
so you want to get something with low K-cat and high Km.
C would be the answer if they asked highest catalytic efficiency.
Yeah.
But they're asking lowest, so it's going to be the opposite of that.
Okay. So, K-cat. I guess I'll just memorize the formula, but...
Yeah.
If you happen to find that... What you were telling me about... Like if I didn't have enough stuff to learn, but I'm just curious to know where it's coming from.
Yeah. It's funny because I found it like yesterday, or no, like maybe on Saturday, but I don't know where I put it.
You want something hot? Hold on a minute. Okay. Wow, not even one. This is the last question of the packet.
Oh, the packet?
Yeah. I mean, there was one more, and it's about hold on, give me 1 second. Did I get confused? There's a chance that. Yeah, that was the last question. And then the one after that, well, it was second, let me see, 69, 69. Yeah. I'm concerned at this point. I wanted to do like some questions on kinematics and stuff of the section bank, and that's why I kind of like left this stuff to do it with you, because we haven't really like review a lot of like physics stuff, but there's nothing else in that section bank that I kind of like run over really quick, and everything I'm kind of familiar with, like a bunch of like amino acids again, enzymes, kinetics, thermodynamics, and stuff like that. Maybe if it includes like on the side knowing one formula or other for physics, but what about like kinematics or fluid, magnetism, all that stuff? Like I didn't see one question of that in the section bank.
Yeah, you might see it in the practice tests though.
Okay.
Right?
I mean, I'm taking
I found the thing.
tomorrow, so. Huh?
Oh, I found the thing I was looking for.
Oh, cool.
Let's see. So, Michaelis-Menten equation. Here, I'll like try. Let's see if I can copy and paste. Whoops. So, okay, so basically, there is. Let's see how I could do this. Okay, wait. I can share that with you later. So wait, you said that you completed all the questions in the sector bank?
Well, yeah, the ones, no, I haven't, but I'm gonna do the other ones on my own, and they were nothing, like, what I wanted to do was questions more related to physics, but I'm going to do the first full length tomorrow, so I guess if I see anything there, that's when I'm gonna, like, check the answers and tell you which ones they are.
Which questions have you not done before that you're saying you want to do on your own?
Like the ones that are left for the section bank for physics and chem, but I was skimming through them looking for other questions related to physics, and I didn't really see anything. Like there was a bunch of amino acid stuff and some kinetics and thermodynamic stuff. So
I mean, is there are there any like passages that kind of involve that?
Yeah.
Oh, which one?
If you want, that involve what, like enzymes and stuff like that?
Oh, just that you want that you like haven't done yet, but you wanted it to do it yourself. Maybe there's like physics aspects of it that you haven't noticed yet.
That's what I'm trying to say. I mean, maybe there is, but skimming through it really quick, I don't see anything passage based.
So which ones? I mean, like, unless you want to work on something else.
Hold on, just didn't. Yeah, let's do the review really quick of the isoelectric focusing and the affinity chromatography.
Okay.
Give me 1 second. Let me open a document that I have here.
Mm-hmm.
Okay, so this was a document that I was using for it, and I don't know, maybe it's going, oh, I'm not sharing my screen. It's going too in depth.
Okay.
So, I mean, I'm okay with Western blotting and Southern and Northern blotting. The Sanger sequencing is fine. But then the stuff with chromatography, especially with ion exchange and um, affinity chromatography, kind of like,
Mm-hmm.
there was a question that I got right, but I did it based on the fact,
Mm-hmm.
like process of elimination. So I don't know how much do I need to know about like this, lab techniques, but I feel that isoelectric focusing is coming up a lot,
Mm-hmm.
at least to know like what is it based on.
Um,
Um,
so basically, isoelectric focusing is based on the isoelectric point, and they first basically just. Uh, so let's see. Separates based on the relative contents of acidic and basic residues. So there's a pH gradient. So you'll basically just have like a part where on the gel that'll have low pH and a part on the gel which will have high pH.
mhm.
And, whatever proteins you have there, they will migrate um, until it matches their isoelectric point. So, like, for instance, in the thing that you have, I see that there's that blue one that has a positive charge.
Okay.
So it's going to move like that arrow. It's going to move like to where it starts to where at that end of that arrow is.
Mhm.
Yeah, and at that point, whatever pH that is, that's the isoelectric point um, for that protein. AKA, it's the pH at which that protein is neutral.
Yes, that makes a lot of sense.
Mm-hmm.
Now for the question of, let me log in here really quick. For the question of the bio section
Oh,
that
1 second.
talks about it. Oh, okay.
I remember I made coffee, but it was too hot, so I put it in the freezer, and now it's frozen solid.
Oh my gosh, that happens to me all the time. So for this weird reason, I think my dad used to do it, and I also ended up doing
Yeah.
the same thing. I love cold coffee, but I won't go to like a coffee shop or make iced coffee. I
Yeah.
like coffee that was hot and now it's cold, and that's how I drink it.
Yeah, I'm glad it didn't like
People are
crack.
like, just order like iced
I'm
coffee,
glad it
but
didn't like
I don't.
crack the thing.
Oh, so now you have to wait until it melts.
Yeah, but I'm glad it didn't crack the cup, the mug that it was in.
Oh, well, as long as it's ceramic, I guess, as long as it's not glass, right? Or can you actually break the ceramic ones as well?
You could break anything like that, um, because it expands as it
Mm-hmm.
freezes. But it probably didn't break because it's open, and I guess ceramic's harder to
Now
break.
you have, that sucks. Now you have to wait for it to be melted. Hold on, I'm looking for the question because I left notes on the question. I was like, to review.
Let me ask you this: if I put in water instead of coffee, would it have taken longer or less time for it to freeze?
It would actually take less time because it has Yeah.
Because of what?
The coffee has more solutes in it.
So freezing point depression, right?
Right.
Correlative properties, good.
I can't find the question.
Oh,
Damn it.
so you're looking for a question on that asks a question about
Yeah, it was a
isoelectric?
I'm done with the biohack, but it said basically, hold on, I know it's like all the way at the end, so I can.
Mm-hmm.
I don't like this system for the AMC, like the way
Yeah.
that you check the questions and stuff. It's not very
Yeah, it's pretty bad.
practical.
Yeah.
Based on the information, which metabolic reaction? No, I can't. I can't find it.
What
It's
would
fine. It said like it was kind of like saying that you have to establish a pH gradient. So I was like, why do you have to establish a pH gradient? And now I understand. So basically, the protein will stop moving whenever it loses a charge.
Yeah.
So whenever it reaches the isoelectric point, which was what they were not explaining on that question. I wish I could.
Yeah, like in that picture that you're showing me, like imagine like on the like it's not really an x-axis, but imagine like along the length of that gel, there's like, pH like whatever, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc.
Which technique cannot be used? No, that's not the one to analyze gene expression. Nope. Okay, whatever, I'll find it. And then so affinity chromatography is based on also.
Okay, yeah,
Whatever.
chromatography is based on something having a greater affinity for a stationary phase compared to a mobile phase. Like that's how all the chromatography kind of works.
Okay.
So, yeah,
for ion exchange, for example.
yeah.
They will separate it by their net charge. So depending on what the column is filled with, so if they're positive or negative, then let's say if it's negative, the positive ones will elute first, or would actually elute because the other ones will bind to the. The negative ones will elute.
So let's say that you have a cation exchange column. So that kind of like the naming kind of like throws you off, or it threw me off. But that basically means that we're exchanging cations. So basically, there will be in the column a bunch of negatively charged beads. So let's say you throw in, a mix or a solution of something, right? The negatively charged beads are going to be attracted to the positively charged proteins in that solution that you pour in, right? And everything else, like the neutral ones and I guess the positively charged ones, will just just go through, like basically leave.
Okay.
Yeah, and then afterwards, what you do is you wash it, so to make it leave. Here, let's see if I could find.
That's why it's called ion exchange, because now you're replacing it with something else. So if you need to wash out those positive ones the negative ones that stay on the positive beads, what would you wash it with?
You would wash it with something that has a greater attraction for the beads. So here, I'm gonna put this image in the whiteboard. So here, I'm going to.
I'll stop sharing.
Okay. All right. So, and it's a time sequence thing. So that the thing on the bottom shows you like the elution curve. So okay, let's say so this over here we have immobilized cation surfaces. And you throw in a mix of proteins, some with positive charges, some with negative charges, right?
Correct.
Okay. Now the thing with the thing that you were showing me, I think it's wrong. Because it's saying, in terms of what elutes first, it's wrong. Or wait.
Let me.
Because I thought.
It says that negatively charged proteins will just like flow through because the beads on the column are negative. But it doesn't really give you an illusion curve.
Okay. All right. I thought I read something different, but yeah. So basically, like, yeah, if it's positively charged, right? The negatively charged ones will bind to the, the beads, and the positively charged ones will just leave. Like just not bind to anything. And so that stuff elutes first.
But how come it doesn't show any peaks?
That's a good question. I think it's because when we look at the elution curve, we're just looking for the elution of like what we want to see, like negative charged ones. Let me double check though. That's a good question.
Unless they kind of like move the additional evolution buffers to separate slightly negatively charges. Oh no, so the two peaks are for those that have. So the ones that elute last will be the ones that have higher affinity for the positive.
Yeah, for the stationary phase. Yeah, I think the elution curve is just based on what we're trying to look for.
Okay.
So yeah. So I think that's why. So because we're trying to look for, this is an anion exchange column, so we're looking for the anions.
Okay.
Okay. So yeah.
So we're looking for the anions. Got it.
Yeah. So first, there'll be elution of the cations because they don't really do anything. And then what you do is, so, when these guys leave, you have, this blue one attached and this green one attached. Right? Okay. Now, what they do is they add an elution buffer, which will just be something that has a stronger, I suppose, affinity to bind to the positively charged stationary phase, or the positively charged beads. So
okay.
So I guess they add some buffer, right? That's going to have a stronger affinity for this bead, but not stronger than the green one.
Okay.
So once they add that, it enables the blue anion to elute. So that's what that is, and that's just to separate the slightly negatively charged molecules. And then after that, they would add, a higher concentration of what they added before to separate the ones that are highly negatively charged and cause those to elute.
So it's the same elution buffer with different concentrations, right?
Yeah.
Okay.
Let's see if I can find anything more. So yeah, so that's like the elution thing. So basically, the thing that will elute last is the thing that has the strongest, like affinity for the stationary phase. And that's something that you'll see in all types of chromatography. You'll see something that just has a higher affinity for the stationary phase, and that's the thing that will, like, if we're talking about something that can be eluted, it'll be the thing that gets eluted last.
Sorry, can you repeat that? If we're talking about something that can be eluded, it would be...
Oh yeah, it would be eluted last.
Okay.
So, yeah. So that's like just for yeah, that's just like in general for any type of chromatography.
Okay.
Yeah. Yeah, so like for instance, if it's like gas chromatography, the thing that's eluted last is like the heaviest molecule. Just because it takes the longest for the heaviest molecule to reach like a gas, to reach the gas phase.
Hold on, I'm looking at gas chromatography. So, it is separate and analyze molecules. It's an...
Ion.
Oh, yeah, because... So, the stationary phase of... Well, but I think it's because you say the heavier ones are the ones that elute first.
Oh, I think elute last.
Yeah, because they're attached to the actual stationary phase.
Mm-hmm.
Okay.
Yeah. There's let's see. Whoops. Gas chromatography. So gas chromatography basically involves like turning something into a gas and running it through like this column, and eventually it basically can elute. Let's see if I can find a better thing for it. Gas chromatography. You know, I should look at like some of my old notes. Okay. Let me look through some of these old notes over here. Well, do you have any questions on any type of chromatography, like in particular?
No, nothing has come up yet. So probably if I see something like on my test, on the practice test.
Oh yeah, it'll definitely come up like somewhat like often. I had like a thing on whatever, like lab techniques somewhere, but not here. Oh, what other material did you have?
For what? Like questions on?
Mm-hmm.
No, because I thought that I was gonna have more questions on the physics section bank, but I can't really find anything related to physics. I mean, I don't.
Oh, I mean, like, what other questions did you? I mean, material did you have like to study with?
Oh, well, UWorld already expired, so I'm not gonna renew it
Oh
again.
yeah, yeah. You rolled. They give
Yeah.
you like next to no time. Like they just give you
UWorld
like a
is
couple
what?
of
I'm sorry.
months. They give you like very little time. Like it's like a couple of months.
Yeah. And then I have the question banks from the AMC, like the ones that are
Mm-hmm.
like the actual question banks, because these are the section ones.
Do you have anything else?
And the practice test. That's it.
The AMC ones.
Mhm.
Okay.
Yeah, I
So
kind of got. Well, I have two from next up, but I don't think I'm gonna. I don't know. Well, I'll
oh yeah,
prioritize doing the AMC.
those are really good because yeah, if you have next step stuff, I would recommend to do those because those have really good like the science the non cars sections for the next step practice tests are really good. They're harder than the AAMC ones, so it's really good practice.
Right. How do you think? So you think I should do the next step first instead of the AMC?
Yeah. Um, yeah, because it's really good practice. How many of the how many tests did you have for that?
For next up, I have two.
Okay,
Yeah.
two. That's a strange number.
Because so what happened is that I'm not gonna buy them. I mean, at this point, it's like that's it. I'm not like spending more money on that.
Yeah.
I have a friend who didn't use the last two, so I have three and four. Like
Okay.
it's how you buy the next step membership or whatever account,
Mm-hmm.
and then it expires up to a certain point. So he already took his test and he told me that he didn't use those two. So if I
Yeah.
wanted to use them, then they were there.
Okay. Um. Yeah, I have access to mine too. If you wanted to use them,
Yeah, I mean, to
because
be
I
honest with
have
you, I kind
all
of got.
10.
Oh, yeah. You got the whole pack.
Yeah. Which tests? Do you know which ones? Your
Three and
friends
four, he said.
3 and 4, and you could take the other ones like multiple times, so you should be have access to that.
Yeah, I don't know why he said three and four. That's true because one of my friends told me if we could just buy the pack together and then we will take it at different times. Because there's like a unlimited, or is it like 6 times? How many times can you take each test?
Yeah, it seems like 5, and I would do it like section by section anyway. Or if you didn't do it section by section, just skip cars.
Yeah, no, cars was like completely unrelated to the actual thing.
Yeah, how is cars going for you?
I already finished everything. I mean, I ran out of material. I literally did everything from UWorld and everything from the AMC. So like
Yeah.
almost like 1,000 questions for cars. I just got really used to it and comfortable.
Okay, so that's
Um,
that's good.
so like I don't think I should be saying I'm not concerned, but because I haven't started the full length, that's the only practice I have left, and I haven't really been. I don't want to use like a third party for cars because I try to do the next step
Oh yeah. The third party
test, and it
stuff
was
for
like
cars
completely
aren't really that
unrelated.
good,
Yeah.
but for next step, the other stuff is actually really good because they're harder than what you would see on the AMC.
Okay.
So
So do you think I should do those instead of like worrying about finishing or working on the question bank?
um well
Question pack, sorry, the Q packs of the AMC.
oh those are like pretty much like old and not really that useful unless they're for cars.
Right, and I already did all the ones for cars, so.
Yeah, and I guess like the section banks you've done already or you're close to finishing.
Yeah, I already finished psych and bio. I did cars already, so the only one I'm missing is this one, chem and physics.
Okay. Yeah, I would say that once you're finished with that, to do the next step ones. So yeah, I check to see if your friend has done like every single attempt because they give you 5 attempts. I doubt that he's done all 5.
I doubt it. If he didn't do 3 and 4, I really doubt that he has done the other ones like multiple times.
Yeah, yeah. So I would highly recommend that you do the next step ones and like treat them as like either you could do 2 things. You could either do them section by section, or you can treat them as a full length but not do the cars section.
How do you think they are for psychology though?
Oh, they're good for that too. They're basically
Is it like related or is completely unrelated like cars?
oh no, it's related. Um, so see how you are with that, but if you're running, low on time, I would just do like the CP and the BB sections from the next step exams.
Okay.
Yeah.
So just do it as a time section. So I guess blocks of 58.
Yeah, because they're going to be tougher than the AAMC ones.
Okay.
Like, when I did like that spreadsheet of the people who scored 100th percentile.
Oh, I was trying to look for that spreadsheet, but I wasn't able to find it. Do you mind if you send me the link for it?
Yeah. But what the spreadsheet basically shows you. Here, let me see what
Yeah, because I was talking to a friend about it, and he's like, "Well, let me see." I'm like, "Yeah, I can't find it anymore."
Well, I try to keep it.
And look for it, and I couldn't
I try
find
to
it.
keep it like like private, kind of just for like my students. But here, let me. I should do like a shared screen for the entire screen. So here. Okay, so this is the. Wait, is this the right one?
Oh no, because you had one on Reddit that you posted once, like in one of your posts. So that was the one that I was trying to look for. But I mean, I read so many posts that
Yeah.
I don't know where I saw and which of them did I see it. So
Yeah. Hold on. That's not
do you
it.
mind like zooming a little? Oh, there you
go. Okay. Yeah. This is it. So yeah. So I sorted out everyone's like all from the sidebar from Reddit. I sorted it by people who got like 523 or higher. Right.
Do you mind like making it bigger because I can't really see the numbers?
Oh yeah, sure. Here. Is it easier now?
No, I didn't really see any change in. If you just click like the actual square to make the window.
Here, I'll just
full size.
do that.
Oh, there you go. Yeah. So, the real shit. Full length, AMC. Okay, so you did it based on full length of AMC and next step.
Yeah, one sec. Okay, so yeah, so these are people from whatever, all these years and stuff. So basically like next step, right? So
right.
The average scores for the next step are these. You see how they're like 5'11", 5.
Oh wow.
Yeah. And if you look at, what people thought about it, like, CP much more calculation based, also much more dense. So that's good, good practice basically. Good practice, but overall harder than the real thing. Good questions for CP and BB, but not to do cars. Difficulty
Not cars.
Much more representative of the actual test. AMC's easier in comparison. Note here, I recommend this, blah blah blah, but basically saying like, well, the PS is so, but the best BB and CP sections out of any other test company. This one, good for stamina. You know, they're just harder, so I would say that they're very, very useful to use. You know, because these.
Well, that's almost like a 12-point difference.
Yeah, exactly. Like
that's insane.
Because then on the AMC test and then actual average test, like it's like a 12-point difference. Yeah.
Oh wow. 508. Wow.
Yeah, so I would definitely recommend that you do the next step.
Yeah, I was running away from next step though, because I mean, after I told you that I took that half length, it was like, what the hell? Like, it's discouraging to see that you have done so many questions and then like you really feel lost. Like yesterday, I was finishing the section bank for bio. I felt like I was able to answer questions like super fast, and I knew like what I was doing and everything. So it's also like a positive thing. It adds up. It's like a cycle. Like you see yourself getting them right, so you want to do more questions. But what happened to me in next step was that I was literally like super lost when I took the half length. And
but now you know that it's like that for everyone. Like in the people who scored in the 100th percentile, like it's that much of a difference.
Okay.
So the scores are like deflated, basically.
Super deflated, I would say.
Yeah. So I would say the best thing for you to do is to do those next step ones, the CP and the BB section.
Okay.
And do them however you want, but you'll be exposed to much more like tougher material.
I'm gonna do that. Yeah, good thing you told me. I'm gonna ask him today. I mean, if anything, I'll probably message you to see if I can access those tests, because it's not super expensive, but right now it's like I'd rather not.
Yeah, of course.
I'm like not working at all, so it's amazing, but it's tough in the other sense.
Yeah. I mean, if anything, I could just like give you access to mine because I'm not really using it. And
okay.
I bought,
but I mean, you're gonna run out of. I guess if someone else is using it or whatever, like you run out of attempts to take them.
Yeah, but I have like plenty of attempts left.
Okay.
So, yeah.
Okay, cool.
I do have to end this session now.
Yeah.
But.
Oh, do I?
Wait, what?
Oh, you have someone else. Right?
Yeah. So, but I'll contact you after that session. But about like what to do and stuff. Okay.
Okay.
All right.
Okay, thank you.
All
Remember to request the money because I can't send it to you otherwise.
Okay. All right.
All right.
Take care.
Thank you.
All right.
All right. You
Bye.
too. Bye.